So again, I have drawn two triangles and suppose that they are similar, ABC and PQR, let us say that. So if these two triangles are similar, then what kind of things will happen? One thing is that the corresponding angle will be the same, exactly the same. Okay, so angle A will be equal to angle P, angle B will be equal to angle Q, and angle C will be equal to angle R. Okay, and then there is another property of similar triangles, and that is the sides are in the same ratio. So what does it mean? So if AB is the side and corresponding side is PQ, similarly BC is the side and corresponding side is QR. AC is the side from first triangle and the corresponding side in another triangle is PR. Okay, so what uh, happens in the similar triangle is that ratio of sides are the same. So what does that mean? Side AB divided by PQ will be equal to side BC divided by QR will be equal to side AC divided by PR. Okay, so this is also very important property which you should remember about similarity of similar triangles. This is also very interesting theorem 6.1, and it states that if a line is drawn parallel to one side of a triangle, so what it is talking about, if a line is drawn parallel to one side of the triangle to intersect the other two sides in distinct point, so it is intersecting at these 2 points. Okay, and DE is parallel to PC, then the other two sides are divided in the same ratio. Okay, so I have already written it here. You can see that I will also first describe the figure. I have made a triangle ABC. Okay, and then I have drawn a line DE which is parallel to one of the sides BC of the triangle. Okay, so that is and then it is the theorem says that if DE is parallel to BC, then it will cut those two sides AB and AC in same ratio. Means AD divided by DB will be AE divided by EC. So this is what need to be proved. Okay, so what we will do here, we will do some construction. So now I will do some construction. Let me do that with a red line. What we will do first, make a perpendicular on AD. Okay, and also make a perpendicular on AE, perpendicular line starting from D. Okay, and let us call it N and E where it cuts. Okay, so that is one thing. Let us also join these 2 points. Okay, now we can just proceed further. You will notice that in in the triangle ADE, in triangle ADE, okay, in triangle ADE, where is triangle ADE? ADE, this is what it is talking about, okay. The area of the triangle, what is the area? Area is half into base into height, okay. And this is why we have made perpendicular NE here, so that we can utilize it in the area formula. So half into what is the base? Let us assume that AD is the base, and then what will be the height? What is perpendicular from AD? It is NE or EN. So this will be the area of triangle ADE, okay. That is okay. And then let us also consider triangle BDE, okay. Which is triangle BDE? Triangle BDE is this one, okay. So here also, in this triangle, base is BD, isn't it? And what is height? Height is again EN, which is not falling inside the inside on this BD, but it is on the same base. Its height is the same, EN, okay. So we have now found the area of ADE and BDE, okay. ADE and BDE. Let us do the same, and then we know that the height is same in both of the triangles, okay. Next, we will concentrate similarly on area ADE. We will look at area of ADE and DEC. ADE and DEC, okay. So in ADE, once we took a triangle ADE before also, but now we are considering, I will just show you here. First we considered this area, okay, and this here area. Now we are considering again ADE and this DEC, okay. So that is the difference what we have done, okay. So and then you will notice that DE is the common height of those two triangles, okay. And then the area of ADC could be written as, what is the base of ADE? It is AE also. This is also the base, okay. So AE multiplied by, then what will be the height? Height will be this one, DE, okay, DE. Similarly, in triangle DEC, what will be the base? Base will be EC. And then height will be the same. Height will be the same, DE. Why? Did you, the same reason as as in the first case. Okay, if you don't understand, maybe I can just um, make a small thing. Okay, I think it's worth making it. You see, this area of a triangle is the height for that triangle is same as for example, if we make another small triangle here. Okay, so this is a small triangle. So for triangle number 1 or triangle number 2, base will differ. Is the base, and this is the base of the triangle number 2, but height for both of them are the same. Okay, common. So this is what is happening here. Okay, that is the point which is quite important to note down, and that is the basis of proving this theorem. Okay, so now as we have done that, we see that in first case, can we take the ratio of ADE and BDE? We can write down. You can write down. We can write down area of triangle ADE is equal to half into AD into EN. Okay, and then what is the triangle of area of triangle BDE? That is half into BD into EN. Okay, so if we take the ratio, what will happen? Half will be cancelled. This will also be cancelled. So we are left with AD divided by BD. What is that? AD divided by BD. Okay, and then for the second equation, we will divide between the area of ADC and area of DEC. Okay, similarly, the DE and DE will be cut. First of all, let me just write it down, otherwise let us go one by one and not go very fast. So DE will be cut and half will also be cut. So this will be AE divided by EC. Okay, so an AE divided by EC, what is that in our figure? AE divided by CE. Okay, area of triangle BDE is equal to area of triangle DEC. How is that? That's very important. That's very important. How is that? Let us again see that how it is going to be. BDE and DEC. Where is BDE? BDE is this area, this triangle, and DEC. The area of these triangles are same. Why? Because if this is the common base DE, and we have been given that this is DE and BC are parallel, so it has the same height everywhere. Okay, so these two triangles have same base and same height. Okay, and if it has same base and same height, then they will be equal. basically. Okay, so if they are same, then what we can write? You may note that in these two ratios, ADE, area of ADE, that is totally same. Okay, and then just now we saw that BDE is equal to DEC. BDE is equal to DEC. That makes these two ratios the same. And then if they are same, then this also has to be the same, isn't it? So this is how we proved that the ratio of two sides, if cut by a parallel line, parallel to base or anything, they are the same. Okay, so BC and DE, these are the two parallel lines. DE was drawn after we made the triangle. Then AD divided by DB will be equal to AE divided by EC. Okay, so that was the theorem. So we have proved it.